Swern oxidation. Swern oxidation is another replacement for toxic chromium compounds oxidation. The Swern oxidation oxidizes primary alcohols to aldehydes and secondary alcohols to ketones using dimethyl sulfoxide and oxalyl chloride, followed by reaction with triethylamine. The actual oxidizing agent is the dimethyl chlorosulfonium ion or the chlorosulfonium salt. This is going to be your actual oxidizing agent. The Swern oxidation is going to do exactly as what the PCC would do to a primary alcohol and a secondary alcohol. Primary alcohols are cleanly oxidized to aldehydes, whereas the secondary alcohols are converted into ketones, whereas the tertiary alcohols are unreactive. Here is a primary alcohol. When it undergoes Swern oxidation using oxalyl chloride and DMSO, followed by reaction with triethylamine, it's going to give us the aldehyde. It's going to give us benzaldehyde. Now, when we look into the next compound, this is a diol. And let's identify what type of alcohols both of these. So this OH group is actually connected to a carbon which is attached to 3 other carbons, which means this is a tertiary alcohol and this part is a secondary alcohol. We already know that this part is not going to undergo oxidation because it looks like a tertiary alcohol. So only this part is going to undergo oxidation. So this under Swern oxidation conditions, wherein we use oxalyl chloride and DMSO in the first step and triethylamine in the second step, is going to give us a ketone. A hydroxyketone is the product that's obtained. In the mechanism of Swern oxidation, there are 2 important steps. The first one is formation of electrophile, which is dimethyl chlorosulfonium ion, which is going to act as our oxidizing agent. And the second step is the actual oxidation of alcohol. This dimethyl chlorosulfonium ion or oxygen should be created from DMSO and oxalyl chloride. Oxalyl chloride is a very strong electrophile. And DMSO, you can look into the structure and see that it's structurally similar to that of acetone, because in acetone we have a carbon here. And also when you look into the DMSO structure, it can exist as 2 resonance contributors. It can have a charge separated on sulfur and oxygen. This resonance contributor is more nucleophilic, and therefore it's going to react with oxalyl chloride. And now let's look into the mechanism of how this dimethyl chlorosulfonium ion is created from DMSO and oxalyl. Let us now look into the mechanism for formation of electrophile dimethyl chlorosulfonium ion. We are going to take the nucleophilic resonance contributor of DMSO and make a nucleophilic attack on oxalyl chloride. Okay. Oxygen, with the electrons, it's going to go attack the carbonyl carbon, and it's going to thrust the electrons into oxygen, but those electrons are going to come back again here, and the Cl is going to leave with its lone pair of electrons. Now in the next step, the Cl- is going to go do a nucleophilic attack on this electrophilic sulfur. And it's going to eliminate a carbon dioxide and a carbon monoxide and a Cl-. So with that, that's going to create the dimethyl chlorosulfonium ion, carbon dioxide, because you can see that this part is actually going to be your carbon dioxide. And this is our carbon monoxide. And then finally, Cl minus 2. Now the next step is the oxidation of alcohol. The oxidation of alcohol actually takes place in 2 steps. The first reaction is actually going to be an SN2 reaction, and then the next reaction is going to be E2 reaction. So it begins with an SN2 reaction and it ends with an E2 elimination reaction. Now let's see how an alcohol is converted into the oxidized product. Primary alcohols are going to be oxidized to aldehydes, whereas the secondary alcohols are going to be oxidized to ketone. Now let's take an example here. Let's take a primary alcohol, and we are going to react it with chlorosulfonium ion. Let's draw the structure for chlorosulfonium ion. Okay, the first step is going to be the nucleophilic attack of the oxygen on the electrophilic sulfur. So oxygen with its lone pair of electrons is going to go attack the sulfur, and it's going to kick out the Cl minus. Remember, oxygen is going to have 3 bonds now, therefore it should have positive charge on it. And the sulfur is also going to be electropositive here. Okay, and in the next step, remember we are using triethylamine. The triethylamine is going to act as a base, abstracting this hydrogen, and it neutralizes the positive charge. And it's going to give us this intermediate. So this step right here can be taken as a SN2 reaction. The one that we are going to do right now is going to be an E2 elimination reaction. E2 elimination. So for an E2 elimination, we need to have the beta hydrogen. So you can think that this is your alpha atom and this is your beta carbon, right? And one of the beta hydrogens need to be abstracted, for which triethylamine is again used. It's going to go abstract this hydrogen, pushes the bond here to form a double bond between carbon and oxygen, and then this is going to be a leaving group. This entire part is going to be our leaving group. Okay, now you have your alcohol aldehyde, and dimethyl sulfide is formed as the side product, is the other product. Okay, and remember, for the oxidation of alcohol using Swern oxidation, the first step is going to be using dimethyl chlorosulfonium, and the first step is going to be the SN2 reaction, and the second step is going to be the E2 elimination reaction.